Hello everyone, in this video we're going to talk about elliptic mesh generation and a code I wrote based on this paper that I'm going to post in the description of the video. So in this paper they explain really carefully the method that we're going to use, and they also explain another interpolation methods. So let's just run the code and see what we're trying to achieve. Basically, we have this domain which is very basic, just 3 straight lines and 1 parabola, and we want to map it into square matrix, a 1 by 1 matrix, so that we can solve PDEs with ease in that domain. So basically what we need to do is solve a Poisson equation in a complex domain, which is going to give us the mapping, and here is the result of the mapping. So let's just take a look at the code. So we're going to define the number of lines that we want in each direction. Let's say the vertical lines, the blue lines, and the horizontal lines, the black ones. So if we put more lines, we're going to get more lines. The maximum iterations, because we have to solve PDEs, so we have to do it by iterations. Then here you can show the process while it's solving, or just get the final result. So we have to initialize 4 curves that are going to be our boundaries, and here I just initialize them. These are the straight lines of the left, the bottom. At the right we are using this function, which is a parabola, and at the top we have another straight line. You notice that for the bottom on the top we use nx, so we have certain number of points, and for the left and the bottom, for the left and the right, sorry, we have ny, which is a different number of points. So this is just a matrix with the parameters, and here is our x matrix, which is going to give the x coordinate of each node, and here is our y matrix that is going to give the y coordinate of each node. And here we initialize our x and y matrices with the curves that we had previously computed. Now we just are going to initiate some temporary matrices for the iterations, and now we're just going to solve the PDEs by iterations as described in the paper that I'm going to post in the description. So each iteration we have to compute the parameters alpha, beta, and gamma, and then we just advance and compute our new x and y and check for the errors. If we update our x and y, and we just break the loop once our errors are below our minimum error, which here I call it error max, but it just doesn't make sense. It should be min. And then we just plot the results. So the interesting thing is because we're solving PDEs, so to get our mesh, so we can use Newman boundary conditions or not. Here I just, in the first example that I showed you, I didn't use Newman boundary conditions. I just fixed boundary conditions for our points. So we're gonna have 2 different results. Now let's say I'm gonna give the y coordinate here some freedom, so I'm just gonna use Newman boundary conditions. The derivative with respect to the normal equals 0, and we're gonna see the result. In order to just keep both results, I'm just gonna open a new figure, and now I'm gonna run the code. And you're gonna see the difference. See, here we're getting some slightly different results. You can see that the mesh that is clearly different, and we have bigger density of points on the bottom, whereas here in the without Newman boundary conditions we have an equal distribution of points in the left curve, which I would prefer to have more points where the domain is more complex. But you have to be careful with the boundary conditions. For example, now you might want to say, why don't we just apply Newman boundary conditions to the right, to the parabola, and see what it gives us? We're just going to try that right away. And you notice that I wrote don't use because the result is not going to be what we want. So now you see that our right boundary is moving and is changing. So we're going to end up with a solution where our right boundary is not the parabola that we wanted at the beginning. We can just compare it with our previous solution. See that this is not a parabola anymore. We have changed the shape. So when you're trying to implement these boundary conditions, just be careful because they can really modify the domain. And I'm gonna post the code in the description. I hope you guys like it, and I'm gonna make some more mesh generating videos. Thanks for watching.